Some time to work on these first ones. So here, 10 squared times 10 gives me 10 to the third power. I've got x cubed, and there aren't any more x's, so I can't do anything else with that, and there's just one y. Here we'll have 20 raised to the 11th power. We're just adding the 3 and the 8. When we multiply two numbers together that are exponents, where we have the same base, we simply keep the base and add the exponents. For this one, same idea. X squared times x to the third would be x to the fifth. Y to the fourth, that's the only y, so that stays. Z to the third times z to the fifth is z to the 8th power. Any questions about that? That should be primarily review stuff from last week when we did those. All right. So here they're just taking this a step further. What if what you're raising to a power already is a power? So they had 5 squared raised to the 5th. That's 5 squared 5 times. Ends up being 5 to the 10th power. So if we have 2 squared to the 4th, that's going to be 2 times 2, 4 times. If we have 2 times 2, 4 times, what do we end up with? How many 2's? We've got 8 2's, so that's 2 to the 8th power. Here we've got 3 to the 7th, so we've got 7 3's multiplied together. Twice. So that's 3 to the 14th power. Here we've got x cubed raised to the 5th, so that's x cubed times itself 5 times. So it's x times x times x, and we're going to have 5 of those. Don't write too big or you'll never get them all in here. So how many total x's do we have multiplied times each other here? 15. And then here, we'll have x times x times x times y twice. So it'll be 6 total x's multiplied together times 4 y's multiplied together. So let's talk about what we're starting with. When we have an exponential expression which means you've got a base raised to some power that is then raised to another power. I guess I don't need to say another, just raised to a power. What do? I'm sorry? Okay. What do we do to get our final answer without having to do all this stuff? True, but what do we also do? Is my answer 10? Is my answer here 10? So we keep the base, combine how? And multiply the exponents. So if we're simplifying 20 to the third raised to the 8th power and write it in a factored form, how many groups of 20 times 20 times 20 would we have? Answer the question that's asked, not the one that you think is going to be asked. We'll have 8 of those. How many total 20s would we have? 24. So 20 to the third raised to the 8th is 20 to the 24th power. Notice they ask, how is that different than 1 part B? Here, are we raising the power to a power? No. We're adding the powers because we're just multiplying these two expressions together. It's not the same rule. All right, let's go on. We talked a little bit about this last week also. Remember that an exponent only applies to what's directly in front of it. That is the base. So it's important to notice that -3 squared, or really, it may be best to read this as, instead of -3 squared, say the opposite of 3 squared. Whereas this would be -3 squared. Do you see the difference? On that first one, are we squaring -3? No, we're only squaring the 3. So it's the opposite of, the first one's the opposite of 3 squared, whereas this one is -3 squared. So 4x cubed is 4 times x cubed. If we put that in parentheses, this is 4x cubed. Not the same thing. All right, let's go on. We've talked about multiplying. Let's talk a little bit about dividing. So AJ was trying to simplify the expression 2 to the 7th over 2 to the 3rd. He started by writing both the numerator and denominator in factored form, then noticed that he had several giant ones. So let's rewrite AJ's expression in factored form and use the idea of a giant 1 to simplify the expression. So if we've got 2 to the 7th, how many 2's are multiplied together? 7 of them. 1, 2, 3, 4, 5, 6, 7. And in the denominator, we've only got 3 multiplied together. 1, 2, 3. So each of these is a big giant 1. Now, in point of fact, people don't normally take the time to write that giant 1 that way. What do you normally do? You normally just do this, right? But really what you're saying is that that's equal to 1. Okay, and that's equal to 1. So what's left are 4 2's multiplied together. That's 2 to the 4th power. So let's do that a couple of more times. So if we got 2 to the 5th over 2 squared.
2 to the 3rd.
So we have 2 times 2 times 2 times 2 times 2 over 2 times 2. Those both divide out to be 1. So that's 2 to the 3rd power. You'll hear people call that canceling. I don't like calling it canceling because it makes it feel like it made it disappear. It doesn't disappear, it's that it's a 1. All right, if we have 3 to the 4th, so 4 3s in the numerator, over 5 3s in the denominator, what is that equal to? Pardon? No? It's 1/3. Now, if you want to say that it is 3 raised to the negative 1 power, that's okay. And we'll talk about negative exponents later. But it's just 1/3. Let's cut to the chase. I think you guys have got the idea. What is this going to be? Y to the 3rd. And what is this one going to be? What about the x part? Not 2x. X squared. What about the y's? Yeah, they're going to divide out. Y divided by y is 1. Y squared over y squared also 1. So we're just left with the x squared. Really? If you're 400 years old, maybe you can make noises like that, but... All right, so what is the pattern here? So when dividing, two exponential expressions with the same base, we're going to keep the base and subtract the exponents. Hey, any questions about that? All right. Let's see. 44. Oh, you've got tons of time. I'll expect you to be working on your assignment. Yes, sir.